All right, we've already solved a system of equations two different ways, by graphing and by substitution. Now let's talk about how to solve a system of equations using a method called elimination. There are a few steps for elimination method. Number one, we want to put both equations in standard form. We want the x to be first plus the y equal to the number. We want to put them in columns. We want all the x's underneath each other, all the y's underneath each other, all the equal to signs underneath each other, and all the numbers underneath each other. So you may need to rearrange things a little bit at first. Number two, if necessary, multiply one or both of the equations by a non-zero number so that the coefficients, the numbers in the front, of one of the variables are opposite. We want to either get our x's to be opposite or our y's to be opposite. It doesn't matter which one. One might be easier than the other, but it doesn't matter. We just want our x's or our y's to be opposite. And what do I mean by opposite? Well, if your x is 3x, then the opposite of that would be negative 3x, right? We want them to be opposite. Step number three, we want to add the new equations together. Once we add those new equations together, the opposite variables should cancel, and that should eliminate one of the variables. We can then solve for the resulting variable, or solve the resulting equation for the one variable. Once we have one answer, we can plug it in to get the second variable. And then again, we can always double check our answers. Let's do a few so that makes more sense. Solve using elimination. All right, do you remember step number one was make sure it's in columns or in standard form? We want our x's underneath each other, we want our y's underneath each other, we want our equal to signs underneath each other, and we want our numbers underneath each other, which it looks like these already are, right? So step number one's already done for us. Step number two is to make either our x's or our y's opposite. If you look at our x's right now, the coefficients are +1 and +1. Those aren't opposite. If you look at our y coefficients, I have a +1 and a -1. Well, look at that. Those are already opposites, right? So we should be able to use the equation the way it is because it's already in columns and the y's are already opposite. This is making it too easy for us, right? We'll get harder in a second, don't worry. All right, so I have my two original equations where my y's are already opposite. Step number three says I should be able to take these two equations and just add them together. So if I do that, I can combine like terms. I've got a 1x plus a 1x, which is a 2x. You notice that the positive y and the negative 1y cancel each other out. And over on that other side, the right side, I have 10 plus 12, which is 22. So now I have a cute little equation with just one variable. I have 2x equals 22. And now I can solve for x by dividing both sides by 2, and I end up getting x equals 11. Pretty cool, pretty fast, right? All right, but that's only half of our answer, remember. Remember, a solution to a system is a point, an ordered pair, an x comma y. So now that we have x equals 11, we've got to figure out what y equals. Now remember, you can plug your x back into either one of your originals and you would still get the same answer. You should anyway, right? So pick one of the two equations, plug in 11 for x, and let's solve for y. I decided to use the top equation. I plugged in 11 for x plus y equals 10. Now let's figure out what y is. If I subtract 11 from both sides, I end up getting y equals -1. So the solution to this system of equations is the point 11, -1. Let's quickly double check by plugging those numbers in to my second equation. If I plug in a -1 for x, an 11 for x, minus, and I plug in a -1 for y, do I get 12? Well, these two negatives make a positive, and 11 plus 1 is 12, so I know it works. All right, let's look at B. It's got to get a little bit harder, right? All right, in B, are my equations in standard form? Are they in columns? X is underneath each other, Y is underneath each other, equal to signs, and numbers? Cool, step number one's done. Step number two, are my X's opposite? Are my Y's opposite? In this case, they're not. The coefficients of my x's are -2 and -1. Those aren't opposites. The coefficients of my y's are 1 and 3. Those aren't opposites. So we've got to do a little bit more work on this one. We've got to figure out what we need to multiply one or both of the equations by to get those either x's or y's to be opposite. It shouldn't matter which one you choose. One just might be easier than the other. So I'm going to go ahead and multiply the top equation by a -3. I picked -3 because my y value on this one is +3, so I need this y value to be a -3. And as long as I multiply every single term in that equation by -3, I should still be balanced and it should still be equivalent, right? So -3 times -2x is a +6x. -3 times 1 is -3y. And -3 times 2 is -6. So my purple are my two new equations. I didn't have to do anything to the second equation because the y was already a +3. I wanted to make the other y a -3 so that they can be opposites. Okay, so now that I have my two new equations and my y's are opposite, I should be able to add these two new equations together and the y should cancel, right? When I combine my x's, I have a 6x minus 1x, which is really a 5x. And on the right side, I have a -6 and a -4, which is really a -10. Now I have one equation with one variable. I can divide both sides by 5, and I end up getting x equals -2. All right, halfway done. If x equals -2, then I need to figure out what y equals. So I'm going to go back to my original system of equations, and I can either plug in -2 to the top equation or the bottom equation in order to figure out what y equals. Either one, you should get you the same answer. It looks like I chose the second one this time. So I have negative, and then I'm going to plug in a -2 for x, so be careful with that double negative, plus 3y equals -4. Now, those two negatives make me a +2 plus 3y equals -4. Now I can solve for y. I can subtract 2 from both sides. I can divide by 3, and I end up getting y equals -2. So I have the solution to the system as -2, -2. You could always double check by plugging in a -2 for x and a -2 for y in the first equation and making sure that it still works. All right, that one was a little bit harder. Here we go. Let's try C. We're going to step it up even more on C. Look at C with me. All right, step number 1. We want to make sure that our equation, our system of equation is in standard form. We want our x's underneath each other, our y's underneath each other, our equal to signs, and our numbers. Ooh, and this one looks like it's a little bit out of order. If you notice that the second equation has the x's and y's flip-flopped. So I need to rearrange those so that the x's are underneath each other. So I'm going to rewrite it with the -5x first, then the +9y next, equal to -6. I haven't changed the value of my equation. I've just reordered my terms. All right, now that they're in standard form and they're in columns, we want to get either our x's or our y's to be opposite. It doesn't matter which one you choose. We should still get the same answer in the end. I would suggest you try both and make sure that you understand how to either do x's or y's no matter what. On this one, I'm just going to pick x's. Right now, my x is 3 and -5, and those are totally not opposite. Well, one's positive, one's negative, but they're not the same number. So I've got to figure out what I need to multiply one or both of those equations by in order to get them to be the same number, kind of like a common denominator. What number can I get 3 and 5 to be that are the same number but one positive and one negative? What would be the common denominator of 3 and 5? Well, 15, right? And so if I can multiply the top equation by 5, that would give me a 15x. Then I would have to multiply the second equation by a 3, and that would give me a -15x, since it's already negative, right? If they were both positive, then I would have to multiply one of them by a negative number. All right, let's do that. Let's multiply the top equation by 5. Make sure you do every single term. Let's multiply the second equation by 3. Make sure you do every single term. And let's see what happens. When I multiplied the top equation by 5, I ended up getting 15x plus 20y equals 65. When I multiplied the second equation by 3, I ended up getting -15x plus 27y equals -18. All right, now that I have my x's opposite, don't I? One's positive 15, one's -15. When I add these two equations together, they should cancel, which is what I want. I want them to eliminate, right? Now I can add my y's together. I ended up getting 47y equals 47. I can now divide both sides by 47, and I end up getting y equals 1. Halfway done. All right, we need to figure out what x is. Now that I have y equals 1, I should be able to go back to my original equation and plug y equals 1 into either of those to figure out what x is. It looks like I chose the top equation, so I have a 3x plus 4 times 1 instead of y equal to 13. 3x plus 4 equals 13. I can subtract 4 to both sides. I end up getting 3x equals 9, and I can divide both sides by 3. 9 divided by 3 is 3, and so I end up getting x equals 3. So the solution to my system is the point 3, 1. If you use the first equation to find x, you could always use the second equation, plug in 1 for y, plug in 3 for x, and make sure that it still works. It should, and we can get 100% on this homework and this test. Make sure that you practice all the different methods: graphing, substitution, and elimination.